Well, when we first started learning about differential equations, one of the simple things we would do before solving one is simply, given a solution, verify that it's a solution to a differential equation. Well, we're going to do the same in this example, only with a system of differential equations. So we are asked to verify that this is a solution of that pair of differential equations. So x is the solution, is this one column matrix times e to the t. So I'm going to write that differently. I'm going to multiply the e to the t in here in just a minute. So let's note first that our coefficient matrix is -2, 5, -2, 4. And then as usual, x, well, we already know what x is, but this is x, and this is our little x is 5 cosine e to the t, and little y would be 3 cosine t minus sine t in parentheses times e to the t. And then x prime is just x prime y prime. And we need to verify, essentially, we verify that x prime is equal to a to the x. That's what we're going to verify. Okay, well, first let's write down what this is. We don't have it explicitly here. We have x. We need to compute this. So x equals 5 cos t times e to the t, and 3 e to the t cos t minus e to the t sine t. So all I've done is multiplied the e to the t out. Maybe I'll be consistent here and put the e to the t to the left of the trigonometric functions. 5e to the t cos t. And that implies that x prime is equal to, these are both functions of t, so we have to differentiate with respect to t. So that means I've got to do the first times the derivative, let me do the second times the derivative of the first, which would be that's the second times the derivative of the first, plus the first times the derivative of the second, which would be a negative sine t. And this one will take a little bit more work. We will have to do I'll do the second times the derivative of the first, so I can just write the same thing here. That's the second, that's the first, let's see, what is it? It's the derivative of the first times the second plus the first times the derivative, which would be a negative sine t. And now I've got to do the same with this one, minus, and it's going to be in parentheses, e to the t sine t, that's the derivative of the first times the second, plus the first times the derivative of the second. Whew. Okay, so if we combine all the like terms, we get that x prime is equal to 5e to the t cosine t minus 5e to the t sine t for the top. That's exactly what we have here. Now, combining the terms here, I hope I didn't get any signs wrong here. I took cosine t times e to the t. Yeah, I think we're good. but I'm going to go to my notes anyways. Combining the like terms here, we get 2e to the t cos t minus 4e to the t sine t. Okay, so we used our solution to determine x, or to determine what x prime was, and now we need to compute this and make sure we get the same thing. So, that ax is equal to -2, 5, -2, 4, times that. X is 5 cos t on top, and then 3 cos t minus sine t. So we need to multiply that out. So we're multiplying this row by that column. So -2 times this is going to be -10 cos t plus 5 times this, which would be, let me multiply that. I'll write it like 5 times 3 cos t minus sine t. That's the first, and then the second row is going to be this row times this column. So -2 times this, -10 cos t -10 cos t plus 4 times 3 cos t minus sine t. I left off the e to the t, didn't I? Okay, so it's this times, there's an e to the t here. So I get an e to the t here and here. And here. And here. Okay, so if we simplify that, I would get, they both have an e to the t, and I've got a -10 cos t, and I have a 15 cos t, so that gives me a 5 e to the t cos t. Looks good so far. And this is a -5 e to the t sine t, which we need. And then on the bottom, if we combine the cosines, I've got -10 e to the t cosine t. I have a +12 e to the t cosine t, so that gives me 2 e to the t cosine t. And then the sine would be, let's see, plus sign there. So this would be 4 e to the t times negative sine t, and we get -4 e to the t sine t. And that is exactly what we wanted. X prime is equal to this, and a to the x is equal to the same thing. So we showed that x prime equals ax, as requested. Now I have just one quick theorem to show you that very similar to one we've seen before when we were talking about individual differential equations. It was called the superposition principle. It also holds for systems of equations. If x1 through xn are all solution vectors of this, so that means that x prime equals a times x1, x prime equals a times x2 all the way up to xn. They're all solution vectors on some particular interval. Then the entire linear combination of those is also a solution. So you can add them all up, or actually you can multiply them by any real number you want to. Any one of them, you multiply each one of them by different real numbers if you want, and you will get another solution. So something very similar to what we've seen with individual differential equations.